Hi everyone, it's Sharmila here from Can Do Teach, and in this video we're going to be looking at the quadratic formula. So I want to talk about what the quadratic formula actually tells us, when it makes sense to use it and when it really doesn't make sense to use it, and we're also going to be looking at a particular part of the quadratic formula called the discriminant. Okay, so let's get stuck into it. Okay, so the quadratic formula is just x equals negative b plus or minus square root of b squared minus 4ac over 2a. And if you tried out the challenge or saw the solution video, you'll see that we actually get this formula by doing a completing of the square on the general form. Okay, so the a, b, and c in this formula relate to the a, b, and c in our general formula. So the thing I want you to notice is that unlike all our factorization methods, this formula isn't giving us a factorized form. It's actually directly giving us the solution to the equation where the quadratic expression equals 0. Okay, so it's not talking about y equals yada yada, it's talking about the thing equaling 0. So what does that actually tell us? Well, remember that our y equals ax squared plus bx plus c gave us the graph of a parabola. Okay, and so where that equals 0 is where y equals 0. So it's giving us our x-intercepts directly. It's straight away giving us the solutions to the quadratic rather than us having to factorize and then solve. Okay, so when I first learned quadratic formula, my first reaction was, well, why did we spend all that time learning to factorize? Why don't we just use this all the time? Well, it's because even though technically it gets us straight to the solution, the actual process of substituting the numbers in and solving it all by hand is actually a lot more time consuming than it first seems. So for something that can be factorized, it's much easier to just factorize it and find the solutions that way. So we'll look at an example of that. So let's take this quadratic as an example, x squared plus 3x plus 2. Now, if you had a bit of practice at this, you'll see straight away that it can be factorized. So we'll do that as our second method later on. But for now, let's try and use the quadratic formula to solve this. So we can straight away say x equals, and what I'm going to do is again say what my a, b, and c are. So a equals 1, b equals 3, and c equals 2. Alright, so I'll start by copying down my quadratic formula. And I rarely memorize formulas, but this is one that you kind of use enough that you should memorize it, or you will eventually memorize it. So if I substitute, b is 3 plus or minus square root of b squared, so 9, minus 4 times a times c is a times c, so 8, and 2a, so 2 times 1 is 2. Now 9 minus 8, that's nice and easy, square root of 1, 2, and square root of 1 is just 1, so it's negative 3 plus or minus 1 over 2. So that is negative 3 minus 1 is negative 4 over 2 is negative 2. Or negative 3 plus 1 is negative 2 over 2 is negative 1. So we're done. Those are our two solutions. Okay, so that one was quite easy because we didn't have to deal with any surds or anything. But let's just see how it goes by factorizing. So if I look at this, I'll immediately think, okay, something that multiplies to give 2 and adds to give 3. Well, there's only one set of factors of 2, and that's 2 and 1, and they add to give 3. So x plus 1, x plus 2. And then if I use the null factor law, I know that this bracket means that x equals negative 1, and this bracket means that x equals negative 2. Therefore, x is negative 1 or negative 2. So I got this exact same solutions as this one, but basically got them straight away. I actually wrote out a lot more steps than I normally would. I could have just looked at that and said, okay, the factorized form is x plus 1, x plus 2. The solutions are x equals negative 1, x equals negative 2. Okay, so even though it does get us straight to the solutions, if we can factorize, it's still preferable to factorize. So let's now look at an example where the quadratic formula does make sense to use. So 3x squared plus x minus 5. Let's try that. Okay, so I would start by thinking about solutions. This is negative 15. So can I think of factors that multiply to give negative 15 and add to give 1? So factors of 15 that have a difference of 1, and I can't think of any. I also don't want to do completing the square because I have a factor, I have a coefficient here, and I also don't have an even number here. So when I factorize this, it's going to be a third, and then dividing that by 2, it's just going to be a mess. So this is actually a really good example of when I would want to use quadratic formula. All right. So again, I start off with going a equals 3, b equals 1, and c equals negative 5. So, quadratic formula. Hopefully you will all have it memorized by the end of the video. 4 times a times c. A times c is negative 15, times 4 is 60, negative 60, so minus negative 60 is plus 60. Oops, not a. 6. Okay, so we've got minus 1 plus or minus square root of 61 over 6. And I can simplify that. I can also, well, I can't simplify that because that third can't be simplified, but I could write it in the 2 separate solutions, or I could enter it into my calculator to see what the 2 separate solutions are. But otherwise I can just leave it like this. Okay, so that gives us 2 solutions. They're not going to be nice whole numbers because we've got a third in there. So they're going to be irrational numbers, but they still give us the x-intercepts on our graph. Okay, so that took about the same amount of time as our previous one did, except this would have been almost impossible to do any other way. So this is a really good example of where you want to use quadratic formula. Okay, so now I just want to draw your attention to this part of the quadratic formula. Okay. So this part is so special that we actually give it a different name and a special symbol. So it's called the discriminant, and it gets this delta symbol. So b squared minus 4ac is the discriminant. So this number, the discriminant, is in the square root part of the formula. Okay? And we have to remember here that when we square root a number, to be able to find a square root, it can't be negative, okay? Nothing squared is a negative number, so I can't square root a negative number. So, we have to think about what would happen if this thing was negative, 0, or positive. Alright? If it was negative, and we tried to square root it, there would be no answers. And if this part of the quadratic formula has no solutions, then the whole thing has no solutions. Okay? If it's 0, then we would have negative b plus or minus the square root of 0 over 2a. And the square root of 0 is 0. So we've got negative b plus or minus 0, so it's just negative b. Okay, so we're going to have the quadratic formula is going to give us x equals negative b over 2a. Okay? There's only one solution, and that's our solution. Alright? And finally, if it's positive, that's when we get our two distinct solutions. Because we can square root a positive, even if it gives us a surd, it's still a number that we can add or subtract from negative b. So that's when we get our two solutions. So this is really handy because just by looking at the discriminant, we can know straight away how many solutions we have. And some of the time, that's all we actually care about, is whether our parabola is going to cross the x-axis and have two solutions, whether it's going to just touch, so this is where it crosses and has two solutions, whether it just touches and just has one solution, or whether it kind of floats and has no solutions at all. Alright, so that can be really important to know, and particularly if it has no solutions, we don't have to waste time substituting everything into the whole quadratic formula because you know you're not going to end up with any solutions anyway. So it can save a lot of time if you just check the discriminant first. So that basically covers quadratic formula. Practice using it, see whether you prefer it or don't prefer it to the other techniques that we've used for solving quadratics, and try to get a handle of when it's useful to use it and when it isn't. Alrighty? Hope that was helpful. If you have any questions, please ask them in the comments below. Otherwise, you can always find extra help at candoteach.com. Thanks for watching, and I'll see you next time. Bye!